Hey, I think this school is kind of small. It's very small.
About 500 students. Yeah.
But 500. I think that by the end of May, I could make all the friends in school.
Yeah, really.
Yeah.
I don't know. Yeah.
As we can see from the previous clips, reality doesn't seem like theory. The question of whether any Fulbright students would get to know everyone is a big question mark to be resolved, since there are various restrictions in creating relations. That is why we have conducted this research on the networking theory to answer the two questions. What would the model of growth in connections for a normal Fulbright student who is neither too popular nor too low-key look like? And the second question is, would this normal student know every single student at the end of the school year?
For our educated guesses, we say that for the first question, the model would follow a polynomial function, as there would be times where Fulbright students would make little friends and other times make lots of friends, unlike the exponential function, where the total number of friends just keep going up at faster and faster rate than before. For the second question, we said that a normal Fulbright student would not be able to make connection with all other Fulbright students by the end of the school year. The reason for that is because there are many periods to point forming, and even students within a big class like me may not have the incentive to get to know everyone.
To evaluate and analyze the model of networking growth, we use the two customary tools of calculus, derivative and second derivative. We'll use the first derivative to evaluate the growth in total connections to analyze the process of new bonds made within each week and predict the growth in bonds until the end of the school year. Using second derivatives, we will be able to determine the strengths of the events and evaluate whether the total number of connections made are accelerating or decelerating.
For collecting data and analyzing them, we divide our work into 5 steps. For the first step, we perform surveying and interviewing. The surveying is done so that we see the starting and estimate number of connections that the participants, as well as observing the events they go to to form our data points for modeling. The interviewing is done so that we get an estimation of how many new connections Fulbright students make weekly. We are lucky enough to have 19 people putting in their answers into our surveys and participate in our interviewing section. These 19 people come from diverse backgrounds and cohorts.
So in the last week, how many new people did you get to know?
It's a good question. I think final season is a perfect season to get to know more people because we get into group of new friends.
For the number of connections made each week, the estimation of friends known per week varies per weeks. For the weeks without events, the responses are 1 to 10, with the average of new connections quantity decreasing through time. For the weeks with events, the number tends to go up substantially. Details of the mean calculation will be shown in the dataset. For the events, the top 3 events are Orientation Week Throwback, Career Day, and Trivia Night. Since these 3 events are held in weeks 9, 14, and 14 respectively after 1st of January, x equals 9 and x equals 14 are corresponding x values for these events. For the y values, we take the mean of the results and deduce the following incrementations.
From this, we are able to deduce our dataset and database. Looking at this data distribution, we see that the best choice of function to follow is the odd power polynomial, as if we translate the graph to the left and downwards and put on the symmetry line. We see it almost look like f minus is equal minus f is. The degree of power we choose is 9, as the graph does not have unexpected jumps or dips and has very high R-square value of 0.9905. Here is our regression line and its formula.
It's therefore concludable that a Fulbright student could not get to know all the Fulbright students' population by the end of the school year.
In conclusion, first of all, the total number of relations follow the polynomial power function in around week 5, 11, and 12. A Fulbright student would make very magnificent number of few relations. The Fulbright student would make the maximum new connection at the first week. Secondly, Fulbrighters would not get to know everyone by the end of the school year. An average Fulbright student with reasonable time spent on campus or socializing with each other, however, can still meet and be friends over 100 other students.
Our research can be improved drastically by increasing the sample size, understanding more clearly the mechanism of networking within Fulbright, and counting in the error terms for our polynomial regressions.